What is happening, everyone? Welcome back to another edition of the Vector Space Talks. I am super excited to be here with you today. As always, we've got a very special guest. We've got Nick, the founder and engineer, founder/engineer of Treeve. And as you know, we like to start these sessions off with a little recommendations of what you can hopefully be doing to make life better. And so when Sabrina's here, I will kick it over to her and ask her for her latest recommendation of what she's been doing. But she's traveling right now, so I'm just going to give you mine on some things that I've been listening to and I have been enjoying. For those who want some nice music, I would recommend an oldie but a goodie. It is from the incredible band that is not coming to me right now, but it's called This Must Be the Place it's from the Talking Heads. Definitely recommend that one as a fun way to get the day started. We will throw a link to that music in the chat, but we're not going to be just talking about good music recommendations today. We are going to get Nick on the stage to talk all about search and rags. And Nick is in a very interesting position because he's been using vector search from Quadrant since 2022. Let's bring this man on the stage and see what he's got to say. What's up, dude?
Hey, nice to
How
be
you
here.
doing?
Doing
Well, it's
good.
great to have you.
Yeah, nice sunny day. It looks like it's going to be here in San Francisco, which is good. It was raining like all of January, but finally got some good sunny days going, which is awesome.
Well, it is awesome that you are waking up early for us and you're doing this. I appreciate it coming all the way from San Francisco and talking to us today all about search and RAG apps. And so I just have in my mind, whenever I say search, I automatically connect recommender because it is kind of similar, but not in this case. You're going to be talking about search and RAG apps and specifically around the OpenAPI spec. I know you've got a talk set up for us. Do you want to kick it off? And then I'll be monitoring the chat. So if anybody has any questions, throw it in the chat and I'll pop up on screen again and ask away.
I'd love to. I'll go ahead and get this show on the road. Okay,
All right.
so I guess the
Sweet.
first thing I'll talk about is what exactly an OpenAPI spec is.
Nice.
This is Quadrant's OpenAPI spec. I feel like it's a good topical example for for a vector space talk.
Very nice.
And you can see here, like Quadrant offers a bunch of different REST API routes on their API. Each one of these exists within this big JSON file called the OpenAPI specification. There's a lot of projects that have an OpenAPI specification. Stripe has one. I think Sentry has one. It's kind of like a de facto way of documenting your API. Even
Could you
like
make your screen just a little, or the font just a little bit bigger? Maybe zoom in.
I think I can, yeah.
All right, awesome. So that my eyesight is not there. Oh, that is brilliant. That is awesome.
Okay,
Yeah,
we doing good here? All right,
that's great.
awesome. Yeah, hopefully, hopefully this is more readable for everyone. But yeah, so like this is an OpenAPI specification. If you look at it inside of a JSON file, it looks a little bit like this. And if we go to the top, I can kind of show the structure. There's a list, or there's an object called paths that contains all the different API paths for the API. And then there's another object called security, which explains the authentication scheme. And you have a nice info section. I'm going to ignore kind of like these two. They're not all that important. And then you have this list of like tags, which is really cool because this is kind of how things get organized. If we go back, you can see these kind of exist as tags. So these items here will be your tags in the OpenAPI specification. One thing that's kind of like interesting is it would be cool if it was relatively trivial to build search over an OpenAPI specification, because if you don't know what you're looking for, then this search bar does not always work great. For example, if you type in search within groups, oh, this one actually works pretty good. Wow, this seems like an enhanced OpenAPI specification search bar. I should have made sure that I checked it before going. So this is quite good. Our search bar for Treeve, an example, does not actually, it does have the same search. But I was really interested in, I guess, like explaining how you could enhance this or hook it up to kind of vector search in order to do RAG on it. And yeah, it's kind of like what I want to highlight here. Okay, so Quadrant has like a really interesting feature called groups. You can search over a group of points at one time and kind of return results in a group-oriented way instead of only searching for a singular route. And for an OpenAPI specification, that's very interesting because it means that you can search for a tag while looking at each tag's individual paths. It is like it's something that's very difficult to build without a system like Quadrant. And kind of like one of the primary, I think, feature offerings of it compared to PG Vector or maybe like brute force with face or usearch or something. And the goal that I kind of had was to figure out which endpoint was going to be most relevant for what I was trying to do in a lot of cases, with particularly Quadrant's OpenAPI spec in this example. To go about doing that, I used a scripting runtime for JavaScript called Bun. I'm a big fan of it. It tends to work quite well. It's very performant and kind of easy to work with. I start off here by loading up the Quadrant OpenAPI spec from JSON, and then I import some things that exist inside of Treeve. Treeve uses Quadrant under the hood to offer a lot of its features, and that's kind of how I'm going to go about doing this here. So I import some stuff from the Treeve SDK client package, instantiate a couple of environment variables, set up my configuration for the Treeve API, and now this is where it gets interesting. I pull the tags from the Quadrant OpenAPI JSON specification, which is this array here, and then I iterate over each tag, and I check if I've already created the group. If I have, then I do nothing. But if I haven't, then I go ahead and I create a group for each tag. I'm creating these groups so that way I can insert each path into its relevant groups whenever I create them as individual points. Okay, so I finished creating all of the groups, and now for like the next part, I iterate over the paths, which are the individual API routes. For each path, I pull the tags that it has, the summary, the description, and the API method. So post, get, put, delete, etc. And I then create the point. In Treeve world, we call each point a chunk, kind of using, I guess, like RAG terminology. For each individual path, I create the chunk, and by including its tags in this group tracking IDs, request body key, it will automatically get added to its relevant groups. I have some try catches here, but that's really the whole script. It's very, very simple to build search over an OpenAPI specification with a tool like Treeve and Quadrant. And I think like really there's something to highlight here and how awesome it is to work with like a group-based system if you're using Quadrant. If you can think about like an e-commerce store. Sometimes you have multiple colorways of an item. You'll have a red version of the sneaker, a white version, a blue version, etc. And when someone performs a search, you not only want to find the relevant shoe, you want to find the relevant colorway of that shoe. And groups allow you to do this within Quadrant because you can place each colorway as an individual point, or again in Treeve world chunk, into a given group. And then when someone searches, they're going to get the relevant colorway at the top of the given group. It's really nice, really cool. And you can see running this is very simple. If I want to update the entire data set by running this again, I can. And this is just going to go ahead and create all the relevant chunks for every route that Quadrant offers. If you guys who are watching are interested in replicating this experiment, I created an open source GitHub repo. We're going to zoom in here that you can reference at github.com/devflowinc/openapi-search. You can follow the instructions in the README to replicate the whole thing. Okay, but I uploaded all the data. Let's see like how this works from a UI perspective. Yeah, Treeve bundles in a really nice UI for searching after you add all of your data. So if I kind of go home here, you can see that I'm using the Quadrant OpenAPI spec data set, and the organization here is like the email I use, nick.k plus OpenAPI. One of the nice things about Treeve, kind of like beyond just the simplicity of adding data, is we use Quadrant's multi-tenancy feature to offer the ability to have multiple data sets within a given organization. So you can have, I have the OpenAPI organization, you can create additional data sets with different embedding models to test with and experiment when it comes to your search. Okay, but I'm not going to go through all those features today. I kind of want to highlight this OpenAPI search that we just finished building. So like, I guess to compare and contrast, I'm going to use the exact same query that I used before. Also going to zoom in. Okay, and that one would be like what we just did, right? So how do I create a group? This isn't a GenAI RAG search. This is just a generic. Search. Okay, so for how do I create a group, we're going to get all these top level results. In this case, we're not doing a group oriented search. We're just returning relevant chunks. Sometimes, or a lot of times, I think that people will want to have a more group oriented search where the results are grouped by tag. So here, I'm going to see that the most relevant endpoint or the most relevant tag within Quadrant's OpenAPI spec is in theory collections. And within collections, it thinks that these are the top 3 routes that are relevant. Recommend point groups, discover batch points, recommend batch points. None of these are quite what I wanted, which is how do I create a group, but it's okay. For cluster, you can see create shard key, delete. So for cluster, this is kind of interesting. It thinks cluster is relevant, likely because a cluster is a kind of group, and it matches to a large extent on the query. Then we also have points, which it keys in on the shard system and the snapshotting system. When the next version gets released, we'll have rolling snapshots in Quadrant, which is very exciting. If anyone else is like excited about that feature, I certainly am. And then it pulls the metrics. For like another thing that might be a little bit easier for the search to work on, you can type in, how do I search points via group? And now it kind of is going to key in on what I would say is a better result. And you can see here we have very nice sub-sentence highlighting on the request. It's bolding the sentence or of the response that it thinks is the most relevant, which in this case are the second 2 paragraphs. The description and summary of what the request does. And like another convenient thing about Treeve is in our default search UI, you can include links out to your resources. So if I click this link, I'm going to immediately get to the correct place within the Quadrant redoc specification. And yeah, like that's kind of the entire search experience. For the GenAI side of this, I did a lot less optimization, but we can experiment and like see how it goes. I'm going to zoom in again, guys. Okay, so let's say I want to make a new RAG chat, and I'm going to ask here, how would I search over points in a group-oriented way with Quadrant? And it's going to go ahead and do a search query for me on my behalf, again, powered by the wonder of Quadrant. And once it does this search query, I'm able to get citations and see what the model thinks. The model does a pretty good job with the first response, and it says that to search for points in a group-oriented way with Quadrant, I can utilize the routes and endpoints provided by the system. And the ones that I'm going to want to use first is /points /search /groups. If I click doc1 here and I look at the route, this is actually correct. Conveniently, you're able to open the link in the, oh, well, okay, this env is wrong. But conveniently, like what this is supposed to do, if I paste it and fix the incorrect portion of the system, changing chat to search, is you can load the individual chunk of the search UI and read it here. And then you can update it to include document expansion, change the actual copy of what was indexed, etc. It's like a really convenient way to merchandise and enhance your data set without having to write a lot of code. Yeah, and it'll continue writing its answer. I'm not going to go through the whole thing, but this really kind of encapsulates what I wanted to show. This is incredibly simple to do. You can get this RAG, this search, and the data upload done in a span of maybe 10, 15 minutes, which is really cool and something that we were only really possible to build at Treeve thanks to what the amazing team at Quadrant's been able to create. And yeah, guys, hopefully that was cool.
Excellent. So I've got some questions. Woo! The infinite spinning field. So I want to know about Treeve, and I want to jump into what you all are doing there. And then I want to jump in a little bit about the evolution that you've seen of Quadrant over the years because you've been using it for a while. But first, can we get a bit of an idea on what you're doing and how you're dedicating yourself to creating what you're creating?
Yeah, at Treeve, we just wrapped up the Y Combinator W24 batch and our seed funding round, which is cool. It took us a year. So Denzel and I started Treeve in January of 2023. And we kind of just kept building and building and building. And in the process, we started out trying to build an app for you to have AI powered arguments at work. It wasn't the best of ideas. That's kind of why we started using Quadrant originally. And in the process of building that, we thought it was really hard to get the kind of amazing next gen search that products like Quadrant offer. Because for a typical team, they have to write a Docker Compose file on their local machine, add the Quadrant service that Docker Compose up-d, stand up Quadrant, set an env, download the Quadrant SDK. All these things get very, very difficult. And kind of after you index all of your data, you then have to create a UI to view it. Because if you don't do that, it can very hard to judge performance. I mean, you can always make these benchmarks, but search and recommendations are kind of a heuristic thing. It's you can always have a benchmark, but the data is dynamic, it changes. And you really in what we were experiencing at the time, we really needed a way to quickly gauge the system was doing. So we gave up on our RAG AI application argumentation app and pivoted to trying to build infrastructure for other people to benefit from the high quality search that is offered by Splade for sparse or sparse encode. I mean, Elastic's ELSER model is really cool. There's all the dense embedding vector models. And we kind of wanted to offer a managed suite of infrastructure for building on this kind of stuff. That's kind of what Treeve is. So with Treeve, you go to, it's more of a managed experience. You go to the dashboard, you make an account, you create the data set, you get an API key and a data set ID. You go to your little script, and mine for the OpenAPI spec is 80 lines. You add all your data, and then boom, bam, bing, bop, you can just start searching. And we offer recommendations as well. Maybe I should have shown those in my demo. You can open an individual path and get recommendations for similar paths.
There were recommendations, so I wasn't too far off the mark. See, search and recommendation, they occupy the same spot in my head.
And Quadrant also offers recommendations for groups, guys. So which is really cool. You can not only can you search groups, you can also recommend groups, which is I think awesome. But yeah, you can upload all your data. You go to the search UI, you can search it, you can test out how recommendations are working. In a lot of cases too, you can like fix problems in your search. So like a good example of this is like we built search for Y Combinator companies so that they could kind of like make it a lot better. Algolia is kind of on like an older search algorithm that doesn't offer semantic capabilities. And that means that you go to the Y Combinator search companies bar, you type in which company offers short-term rentals, and you don't get Airbnb. But with like
That's so
Treeve, like
crazy.
it is. But with Treeve, like the magic of it is that even like believe it or not, there's a bunch of YC companies that do short-term rentals, and Airbnb does not appear first naturally. So with Treeve, like we offered a merchandising UI where you put that query in, you see Airbnb ranks a little bit lower than you want. You can immediately adjust the text that you indexed and even add like a re-ranking weight so that it appears higher in results. Do it again and it works. And you can also experiment and play with the RAG. I think like RAG is kind of a third-class citizen in our API. It turns out like search and recommendations are a lot more popular with our customers and users. Um, but yeah, like Treeve, I would say like to encapsulate it, Treeve is an all-in-one infrastructure suite for teams building search recommendations in RAG, and we bundle the power of databases like Quadrant and next-gen search ML AI models with UIs for fine-tuning ranking of results.
Dude, the reason I love this is because you can do so much with a like well done search that is so valuable for so many companies, and it's overlooked as like a solved problem, I think, for a lot of people, but it's not, and it's not that easy as you just explained.
Yeah, I mean, like we're fired up about it. I mean, like even if you guys go to like yc.treeve.ai, that's like the Y Combinator company search, and you can A/B test it against like the older style of search that Algolia offers or like um, Elasticsearch offers, and like it's to me it's magical. It's like it's an absolute like work of human ingenuity and amazingness that you can type in which company should I get an airbed at, and it finds Airbnb despite like none of the keywords matching up. And I'm fired up about like right now our brains are trained to go to Google, and on Google the search bar you can ask a question, you can type in abstract ideas and concepts, and it works. But anytime we go to an e-commerce search bar or
Oh, they're so bad, dude. They're so bad. Everybody's
and
had
our
that
yeah
experience too, where I don't even search. Like I just am like, well, all right. I'll go to Google and search specifically on Google for that website, and like put in parentheses.
we're just excited about that. Like we're trying to make it a lot like the goal of Treeve is to make it a lot easier to power these search experiences with the latest gen tech and help fix this problem. Like especially if AI continues to get better, people are going to become more and more used to like things working and not having to hack around faceting and filtering for it to work. And yeah, we're just excited at Treeve like to make that easier for companies to work on and build.
So there's one question coming through in the chat asking where we can get actual search metrics.
Yeah, so that's like the next thing that we're planning to add. Basically, like right now at Treeve, we don't track your users as queries. The next thing that we're like building at Treeve is a system for doing that. You're going to be able to like analyze all of the searches that have been used on your data set within that like search merchandising UI or maybe a new UI, and like adjust your ranking, spot fix things like the same way you can now, but like with the power of the analytics. The other thing we're going to be offering soon is dynamically tunable cross encoders. So cross encoders are kind of like this magic neural net that can zip together full text and semantic results into a new ranked order. And they're kind of like underutilized, but they're also hard to adjust to over time. So we're going to be offering like API endpoints for uploading, like for doing your click through rates on the search results, and then dynamically, like on a batched timer, tuning a cross encoder to adjust ranking. Um, and this should be coming out in the next 2 to 3 weeks. But yeah, like we're just now getting to the analytics hurdle. We also just got to the speed hurdle. So like things are fast now, as you guys hopefully saw in the demo. It's like sub 50 milliseconds for most queries. P95 is like 80 milliseconds, which is pretty cool. Thanks to Quadrant, by the way. Like
Nice.
Quadrant is huge. I mean, uh, for powering all of that. But yeah, like analytics will be coming next 2 or 3 weeks. We're excited about it.
So there's another question coming through in the chat, and uh, they're asking, I wonder if LLMs can suggest GraphQL queries based on schema, as it's not so tied to endpoints.
I think they could. In the system that we built for this case, I didn't actually use the response body. If you guys go to devflow inc/OpenAPI-search on GitHub, you guys can like make your own example where you fix that. In the response query of the OpenAPI JSON spec, you have the structure. If you embed that inside of the chunk as like another paragraph tag, and then go back to doing RAG, it probably can do that. I see no reason why I wouldn't be able to.
So I just dropped the link in the chat for anybody that is interested. And now let's talk a little bit for these next couple minutes about the journey of using Quadrant. You said you've been using it since 2022. Things have evolved a ton with the product over these years. Like, what have you seen? What's been the most value add that you've had since starting?
I mean, there's so many. Like, okay, the one that I have highlighted in my head that I wanted to talk about was I remember in May of 2023, there's like a GitHub issue with like an Algora bounty for API keys. And I remember like Denzel and I, we'd already been using it for a while, and we kind of like knew there was no API key thing. There's no API key for it. And we were always like joking about it. We were like, oh, we're so early. There's like not even an API key for our database. You had to like have the access permissions in your VPC or like, subnet routing to like have it work securely. And I'm not sure it's like the highest. I'll talk about some other things that were higher value add, but I just remember like
That was
how
the
cool
state.
that was.
Yeah,
Yeah,
that
yeah,
was the
yeah.
state of the nation when you found out
Yep.
about it.
And it was
Very
so
cool.
hyped. Like the API key got added, and we were like, "Wow, this is awesome." It was kind of like a simple thing, but like for us, it was like, "Oh, whoa, we're so much more comfortable in security now." But dude, Quadrant's added so many cool things. Like a couple of things that I think I'd probably highlight are the group system. That was really awesome when that got added. I mean, I think it's one of my favorite features. Then uh, after that, I like the sparse vector support and like a recent version was huge. We had like a whole crazy subsystem with Tantivy. If anyone watching knows the crate Tantivy, it's like a full text. It's like a Lucene alternative written in Rust. And we like built this whole crazy subsystem. And then Quadrant like supported the sparse vectors, and we were like, "Oh my god, we should have probably just like worked with them on the sparse vector thing." We didn't even know what you guys wanted to do, because like we
Yeah.
spent all this time building it and probably could have like helped out with that PR. We felt bad because that was really nice when that got added. The performance fixes for that were also really cool. Um, some of the other things that like Quadrant added while we've been using it that were really awesome. Oh, the multiple recommendation modes. I forget what they're both called, but there's it's also like insane for people like out there watching. Like try Quadrant for sure. It's so good compared to like a lot of what you can do in a PG vector. There's like this recommendation feature is awesome. Typically, when you do recommendations, you take the results that you want to base recommendations off of, and you build like an average vector that you then use to search. Um, Quadrant offers a more evolved recommendation pattern now, or where you can like traverse the graph looking at the positive point similarity, then also the negative similarity. And if the similarity of the negative points is like higher than that of the positive points, it'll ignore that edge when it's doing recommendations. And for us, at least, like with our customers, this improved their quality of recommendations a lot when they use negative samples. And we didn't even find out about that. Like it was in the version release notes, and we didn't think about it. And like a month or two later, like we had a customer that was like uh, communicating that they wanted higher quality recommendations, and we were like, "Oh, okay. What is like? Are we using all the features available?" And we weren't, and that was cool.
The fact that you understand that now and you were able to communicate it back to me, almost like better than I communicate it to people, is really cool. and it shows that you've been in the weeds on it and you have seen a strong use case for it, because sometimes it's like, okay, this is out there. It needs to be communicated in the best use case so that people can understand it. And it seems like with that e-commerce use case, it really stuck.
This one was actually for a company that does search over American legislation called.
Oh, I was
Funny
blown.
enough, we want more e-commerce customers for Treeve. Most of our customers right now are like SaaS applications.
Mm,
This particular customer, I don't think they'd mind me shouting them out. It's called Bill Track 50. If you guys want to like search over U.S. legislation, try them out. They're very, very good. Um, and yeah, they were they were the team that really used it. Um, but yeah, it's like another cool thing I think about infrastructure like Quadrant in general, and it's so powerful that like a lot of times it can be worth like getting an implementation partner. Like
mm,
even if you're gonna use Quadrant, like the team at Quadrant is very helpful, and you should consider like reaching out to them because they can probably like help anyone who's gonna build search and recommendations to figure out like what is offered and like what can help on a high level, not so much like a GitHub issue code level, but kind
mm.
of like at a high level thinking about your use case. And again, like search is such a heuristic problem and so like human in a way that
Yeah.
it's always worth like talking through your solution with people that are very familiar with search
Yep.
and recommendations in general.
Yeah. Yeah. And they know the best features and the best tool to use that is going to get you that outcome you're looking for. So, all right, Nick, last question for you. It is about Treeve. I have my theory on why you call it that. Is it retrieve? You just took off the re?
Yes, drop the re. It's cleaner. That's like
Yeah.
the Facebook quote, but for tree.
I was thinking when I first read it, I was like, oh, it must be some French word I'm not privy to. And so it's cool because it's French. You just got to put like an accent over one of these E's or both of them. And and then it's even cooler. It's like luxury brand to the max. So I appreciate you coming on here. I appreciate you walking us through this and talking about it, man. This was awesome.
Yeah, thanks for having me on. I appreciate it.
All right, for anybody else that is out there and wants to come on the Vector Space Talks, come join us. You know where to find us. As always, don't get lost in the Vector Space. We will see you all later.